Okay, now we're going to do notes of a right triangle trig, which you learned in geometry, but these are just reminders, kind of reminding you of SOHCAHTOA. All right, so sine is the opposite over hypotenuse, cosine's the adjacent over hypotenuse, tangent's opposite over adjacent, cosecant's the reciprocal of sine, so it's hypotenuse over opposite, secant's the reciprocal of cosine, so it's hypotenuse over adjacent, and cotangent's a reciprocal of tangent, so adjacent over opposite. So let's do some examples. All right. So here we have, it wants us to find the exact value of these 6 trig functions. This is a 3, 4, 5 triangle, and we could do Pythagorean theorem to figure out that 4 if you can remember that it's a 3, 4, 5. But remember the sine of the angle theta, that's the opposite over hypotenuse, so it's going to equal 4 over 5. Cosine of the angle is adjacent over hypotenuse. Remember that hypotenuse is always across from your right angle. And then this side, if this is your reference angle, this 3 right here, that's right next to it, so it's adjacent. So cosine of the angle will be 3 over 5. Tangent of the angle will be opposite over adjacent, so it's going to be 4 over 3. And then cosecant of theta is a reciprocal of sine, so it'll be 5 over 4, or it's the hypotenuse over opposite. Secant of theta will be 5 over 3, or it's hypotenuse over adjacent. And then cotangent of theta is 3 over 4, or it's adjacent over opposite. All right, another example that you might see is a problem like this, where we're asking you to basically solve the triangle, find all the missing parts. So we can find angle B pretty easily because the angles in a triangle add up to be 180 degrees. So we'll do 180 minus the 90 minus the 40 to get angle B. So angle B will equal 50 degrees. So this angle right here is 50 degrees. And then we can use either of those angles, the acute angles, and this side that they have given to me right here to figure out the other 2 missing sides. So if I use this as my reference angle, this is the adjacent side, this is opposite, and I can use, if I'm going to think about which trig function uses opposite and adjacent, it would be tangent. So we'll say tangent of 40 equals the opposite side, which is A, over the adjacent side, which is 2. So solving this, I need to undo what's happening to A, so we're going to multiply both sides by 2. So what I'm typing in my calculator would be 2 tangent 40 to equal A. So when you type this in, you just need to make sure that you're in degree mode. And I get that A is 1.678. So something to consider is the fact that 40 right here is my smallest angle. The side that's across from it should be the smallest side. So we just got that it's 1.678, and it's smaller than 2, which is across from the angle that's bigger than it, so that makes sense. Okay, to figure out this C right here, this is the hypotenuse. I'm going to use the adjacent side in the hypotenuse, which would mean I'm using cosine. So cosine of 40 equals the adjacent over the hypotenuse. Anytime C is on the bottom, we can just switch those two. So that becomes C equals 2 over cosine 40. All right, and then I'm going to type that in my calculator. And I get 2.611 when I do that. And that should be the biggest side because it's across from the biggest angle. And it is, so we did that right. All right, let's do another example. Okay, on this one, I can find C this time because I can use Pythagorean theorem because I've got 2 sides of the right triangle. So I'll do 2 squared plus 3 squared equals C squared. That's 4 plus 9, which is 13. So C equals the square root of 13. And now I'm going to figure out my 2 angles, A and B. So if I'm going to think of A first, this side over here is opposite. This other side right next to it is adjacent. So the trig function that uses opposite and adjacent is tangent. So we'll do tangent of A equals 3 over 2, opposite over adjacent. And now I'm going to solve for A. So that means I have to undo what's being done to A. And what's being done to A is that we're taking the tangent of A. So to undo it, I need to do tan negative 1 of tangent A. To undo it, that's tan negative 1 is the inverse of tangent. And then I have to do the same thing to the other side. So on the left-hand side, those cancel each other out. So you're left with A equals. So what we're going to do is type in our calculator. To get this, I hit second and then tangent, and then type in that fraction 3/2 to figure out what A is. And I get 56.310 degrees. I want to make sure I put the degree symbol because otherwise we're talking about radians, which would be a completely different angle. All right, to get angle B, I'm going to do 180 minus 90 minus that 56.310 degrees. And I get 33.690 degrees. All right, same process. So I want you to think about how this is saying cosine of theta equals 8/10. Well, I could write 8/10 as a fraction, and I could even simplify it if I wanted to. And then it wants us to find the sine and the tangent of that same angle. So I'm going to draw a right triangle. I'm going to label one of the acute angles theta. And knowing this is cosine, remember cosine of the angle equals adjacent over hypotenuse. So if this is the fraction I get for that angle, I know the adjacent side is 4 and the hypotenuse would be 5. And then I could use Pythagorean theorem to figure out that this is 3. And then I can figure out the sine. The sine of theta is the opposite over hypotenuse, so it'll be 3/5. And then the tangent is opposite over adjacent, so it will be 3/4. Okay, same rule will apply here. This is saying tangent of theta equals 3, which means tangent of theta is equal to 3 over 1. And then tangent is the opposite over the adjacent. So when I draw a triangle, and I label one of the acute angles theta, the side that's opposite will be 3, the adjacent side will be 1. I can use Pythagorean theorem to figure out the hypotenuse. So that gives me 10 equals c squared, which means c equals the square root of 10. So that's square root of 10. Now they're asking me to find the cotangent and the secant. So cotangent theta is the reciprocal of tangent, so it will be 1 over 3, or adjacent over opposite. And then B is asking for the secant of theta. Secant theta is reciprocal of cosine, so it will be hypotenuse over adjacent. So square root of 10 over 1, which is just square root of 10. Okay, now I want to go back and talk about some of these trig identities. I want you to know the reciprocal identities, which means that sine of theta is the same thing as 1 over cosecant. Cosecant's the same thing as 1 over sine. Cosine's the same thing as 1 over secant, and secant's the same thing as 1 over cosine. So if I gave you something like, if I were going to ask you for the secant of 30 degrees, you can't really type that in your calculator. And so what you're going to type in your calculator is 1 over cosine of 30 degrees, because that'll be the same exact thing. And then tangent of theta is the same thing as 1 over cotangent, which means cotangent's the same thing as 1 over tangent. You can type these in your calculator, and you'll have to do these in your calculator to get the others. All right, then the quotient identities tell me tangent's the same thing as sine over cosine. Remember, whenever you have your x, y on your ordered pair, the x is the cosine and the y is the sine. And we said that tangent was the same thing as y over x, which means it's the same thing as sine over cosine. And then cotangent's the reciprocal, so it's the same thing as cosine over sine. All right, now let's talk about these Pythagorean identities right here. Let me erase this stuff right here. Okay, so something I want you to think about is the fact that we have a unit circle where my radius is 1. And then we've been talking about it where we draw a right angle to the x-axis where this is the x value and this is the y value. And if I wanted to use the Pythagorean theorem with this picture, I would say x squared plus y squared equals 1 squared. Now we've been talking about how, again, we have an xy point right here on our unit circle, and x is the cosine and y is the sine. So I can replace this x squared with cosine squared theta, because reference angle's theta, plus y squared, which is sine squared theta, and it equals 1. And that is one of my Pythagorean identities, which we have right here. Now if I want to get the other two, I'm going to take this and I'm going to divide it by cosine squared theta. So I will say cosine squared theta divided by cosine squared theta plus sine squared theta divided by cosine squared theta equals 1 over cosine squared theta. So this becomes 1 plus, this is the same thing as tangent. My goodness, I'm sorry. This is the same thing as tangent squared theta. And that equals 1 over cosine squared is secant squared theta. So that's where we got this one. To get the last one, I'm going to take that same beginning identity that we got, and we're going to divide everything by sine squared theta. So cosine squared theta over sine squared theta plus sine squared theta over sine squared theta equals 1 over sine squared theta. So this will be cotangent squared theta plus 1 equals cosecant squared theta. And that's your last identity. So I'm kind of walking you through those because you'll have to remember them, so I want to make sure you know how to get them. Okay, now that we've walked through those identities, we're going to use them on example 6. So when you use trig identities, we're going to transform just one side, which means one side will stay the same. We won't touch it. We're not going to touch that one. We're going to make this side look like that side. And so I'm going to rewrite the secant theta as 1 over cosine theta because it's the same thing. So I can show that that equals 1. Well, remember, this is understood to be over 1, and if you multiply straight across, I get cosine theta over cosine theta, which does actually equal 1. So we've proven that 1 equals 1. So again, when you use trig identities to transform one equation to the other, I want to keep this side exactly the way it was the whole way down. We're just making the left-hand side look like that one. Okay, this next one, I want to think about how a plus b is this, when I multiply it times a minus b gives me a squared minus b squared. Because we've got the same thing in both sets of parentheses, but one has a plus and one has a minus. So when I multiply that out, I get secant squared theta minus tangent squared theta equals 1. And one of our trig identities up there said that 1 plus tangent squared theta equals secant squared theta. If I move the tangent squared over there, I'm going to get 1 equals secant squared theta minus tangent squared theta. So 1 equals that. So I can just go ahead and say that 1 equals 1, and I verified it. Okay, application problems for trig. This right here is someone's horizontal line of vision. This is someone's horizontal line of vision. Each of those lines are parallel to each other. This right here is a transversal going through those parallel lines. And we've talked about before in geometry how this angle and this angle are alternate interior angles, and they're going to be congruent to each other as long as these lines are parallel to each other. Well, this person that's down here, he has to look up to see the guy above. So this is his angle of elevation. This guy had to look down in order to see the guy below, and so this is the angle of depression. Well, the angle of elevation and the angle of depression are always the same. And when we usually draw our triangles, it's going to look like this triangle right here. And so the angle of depression won't be inside the triangle, but it should equal the same thing as this angle of elevation. So I would just mark it here where the angle of elevation is. All right, let's do an example. Okay, on this picture, we've got a surveyor standing right here, and he's looking up at the top of a tree. He's 50 feet away. He's using like a clinometer or something to see what the angle is to the top of the tree. So his angle of elevation is 71.5. So basically we have a picture that looks like this, where he's 50 feet away and he's looking up at 71.5. And we're trying to figure out the height of the tree. Well, using our trig, this is our reference angle. The side all the way across from it is opposite, and the side right next to it is adjacent. So the trig function that uses those two sides is tangent. So tangent of 71.5 equals the opposite over hypotenuse. Now we're solving for h, so we'll undo division by multiplying. So 50 times tangent of 71.5 equals h. And I'm going to type that in my calculator. And I get that the height is 149.434 feet. Okay. Right here we have a person standing over here, and he's 200 yards away from the water. Well, he wants to walk along this path right here to get to the water rather than walking that 200. So we're going to figure out what angle that path made with the river. So this side that's all the way over here, that's opposite. The side across from your right angle is the hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So we'll say sine of the angle equals opposite over hypotenuse. So sine of some angle, theta, we don't know yet, we're trying to figure it out, equals 200 over 400. Well, I'm going to simplify that to be 1/2. This actually happens to be one of the angles on our unit circle. So if you think about a triangle where the angle right here has an opposite side that's 1 and a hypotenuse is 2, that would mean this side ends up being square root of 3. This is one of those 30-degree angles. So theta equals 30 degrees. All right, on the last example, we're trying to figure out how high that statue is right there. So basically, you've got two pictures here. It's kind of hard to see that. You know, here's your building, and here's your statue right here. I'll kind of make it look like a person. I don't know really what it looks like. But you're standing over here, and you're looking at the top of that statue at a 56.5 degree angle. And you're looking at the bottom of that statue with a 55.1 degree angle. And you're trying to figure out how high that statue is. So basically you're going to be thinking about your height from the top right here. And then your height from the bottom of that statue, which would be from right here. And then you're going to subtract those two to get this height right there. So you should really just be thinking about two separate triangles. You've got one where the angle is 56.5, and you are 400 feet away, and you're trying to figure out how high it is to the top of that statue. And then your other triangle is still 400 feet away, but now your angle is 55.1. And you're trying to figure out how high it is to the bottom of the statue. So the height of the statue will be the height of the top minus the height of the bottom. Well, in these pictures, you've got the opposite and the hypotenuse, so we're going to use tangent. So tangent of 56.5 equals the opposite over the hypotenuse. Or I'm sorry, the opposite over the adjacent. I'm sorry, I was saying that wrong. It's opposite over adjacent. So solving this, we're going to do 400 times the tangent of 56.5 equals the height to the top. And I get 604.334. Now we're going to do the tangent of the other angle equals its opposite over adjacent. So we'll be typing in 400 tangent 55.1. And that's getting the height to the bottom. So when I type that in, I get 573.387. So we're going to subtract those two. We're going to say 604.334 minus 573.387. And when I do that, I get 30.947. What units? Feet. And that's my answer.